Let's do some resistor problems next. When it comes to these problems, there are three things you have to remember. Number one, it's all about the diagrams. Diagrams, diagrams, diagrams. Draw them, redraw them, label them, keep them neat. Second, things in series are things that are all in a row, everything in a line with no branches in between. Things in series all have the same current. Things connected in parallel are top to top and bottom to bottom. I'll show you those as we go through. So not all in a row. Things in parallel have the same potential. We'll have to remember these things and we'll have to include them in the drawings as we go. So for this problem, VAB is 20 volts. Determine the equivalent resistance of the circuit. Redraw the circuit first. So I'm going to redraw this circuit. First I'm going to redraw it with all the same resistors, but I'm going to get rid of this triangle because it doesn't please me at all. So for this branch right here, what we have to remember is these straight lines represent pieces of wire. So here I've got my headphones, piece of wire. So it goes from here to here and then down like this. I don't care for the fact that's at an angle, so I'm just going to take it and straighten it out like that because I can. This is just bendy wire. I can draw it straight or I can draw it bent. It's still the same wire. Okay, so for my first redrawing of the circuit, I'm going to keep my battery, keep my 4 ohm resistor, keep my point A. Down here on the bottom I've got my 6 ohm resistor, got my point B. I'm also going to take this wire and straighten that up. So between A and B is a 10 ohm resistor. Okay, 4 ohms, 6 ohms, 10 ohms. I also know that the potential between points A and B is 20 volts. Okay, so I'm going to label that here as well. Thinking ahead, you might understand that knowing the potential and the resistance, you could find the current through that branch. That's going to get to be important. Okay, now I'm coming out to this second branch. I've got my 8 ohm and my 2 ohm, and it comes back to point B. Alright, all I've done here is I've bent the wires a little bit, but now that I've got them all bent, I can see more easily. I'm going to look for my first obvious connection. As I go from 4 to 10, that's not clearly series or parallel, that's not useful. 10 to 6, not clearly series or parallel, not useful. 8 to 2, those are right in a row. I can go from 8 to 2 with no branches, nowhere to veer off. So 8 and 2 are in series. And typically that's how you start these problems. You work from the end farthest away from the battery and you work in towards the battery. These are in series. To get your R equivalent in series, you add your 2 resistors, 8 ohms plus 2 ohms to give me 10 ohms. Okay, now you do a new diagram. Put in your battery, your 4 ohm resistor, point A, 10 ohms, point B, 6 ohms. And now I take out my 8 and my 2 and I put in a 10 because that's what an equivalent series is. Alright, now I look for my next connection. This 10 is attached to the top of this 10. This 10 is attached to this bottom of this 10 is attached to the bottom of this 10. These two are top to top and bottom to bottom. These two are in parallel. When we deal with parallel resistors, we know we have to do the reciprocals. Now you can either do this in your calculator or you can stick with the fractions. I like me some fractions, so I'll go with that. Then to get your equivalent resistance, you have to take the inverse of both sides, 5 ohms. Okay, I've got that equivalent. I'm going to draw a new circuit. Okay, if I look at these resistors, I go from the 4 right into the 5, right into the 6. No branching anywhere over those 3 resistors, so they're all in series because they're all right in a row with no branches. So my R equivalent then is 4 ohms plus 5 ohms plus 6 ohms. 4 and 6 is 10 and 5 is 15 ohms. You draw your diagram one last time. Ohms with your potential V. Okay, so that's the first part answered. We were asked to find the equivalent resistance of the circuit. We get 15 ohms. Okay, next part. What is the current through the 8 ohm resistor? What's the current through right here? If we're going to answer this, we have to come back to our idea of things in series have the same current, things in parallel have the same potential. And let's look at our pictures and let's see what we have. So right off the bat, I know that in this branch from A to B, there's a potential difference of 20 volts because that's what's given. So 20 volts here, 20 volts here. I'm going to come back and I'm going to draw on this diagram. So this is 20 volts. These two are in parallel. This one is also 20 volts. This 10 ohm resistor has a potential of 20 volts. So my current, we know Ohm's law tells me V equals IR. So my current I is V divided by R, 20 volts divided by my resistance of 10 ohms equals 2 amps. Okay, so my current through this branch is 2 amps. Now, we weren't asked about the current through this one. I found it because I looked at this picture and I realized I could find it. So things in parallel had the same potential. Because it has the same potential, this one has 20 volts, so this one has 20 volts. When I know the potential and the resistance, I can find the current. The reason I'm going to find this useful now is because I remember where this 10 came from. This 10 came from the series combination of the 8 and the 2. And what I remember about series is they have the same current. So if there's 2 amps running through this 10 ohm resistor, because this 10 ohm was a series combination of this 8 and this 2, there must be 2 amps running through both of these resistors. Okay, so because they're in series, they have the same current. This one's 2 amps, this one's 2 amps. 2 amps runs through the 8 ohm resistor and then it runs through the 2 ohm resistor. So 2 amps. Okay, power supplied by the battery. If I want to think about the power supplied by the battery, I'll look down at my last picture. I know that my power supplied by a battery, why don't I use a blue pen now for a different color? Power supplied by a battery is current times potential. I don't know V of the battery. I don't know my current yet either. If V is equal to IR, then I can find my power by doing I squared times R. I kind of like this idea. My R is 15 ohms, and I think I can use some of this information to find my current going through this branch. Okay, so that's where I'm going with this. So if I can figure out my current I, then I can use my I and my resistance of 15 ohms to find my power dissipated in the resistor, so that has to be the same as the power supplied by the battery. Okay, so let's go back to what I knew from up here. The potential across this 10 ohm resistor was 20 volts. These two are in parallel, they have the same potential, and this 5 ohms was the parallel combination of these two 10s. So I added these two 10s in the parallel way and I got a 5 ohm. What that tells me is they have to have the same potential. Okay, because this 5 ohm is the parallel combination of these two 10s. So that means this has a potential of 20 volts. I know the potential and the resistance. I can find the current. I equals V over R. 20 volts divided by my resistance of 5 ohms, 20 over 5 gives us 4 amps. Okay, so I know that there's 4 amps running through each of these 3 resistors because they're all in series. So this 15 was a series combination of the 4, the 5, and the 6. So the current running through this 15 ohm, sorry if my voice sounds funny, I have to sneeze so bad and I'm holding it in. The current running through this 15 ohm resistor is the same as the current running through the 4, 5, and the 6. It's the 4 amps. Okay, now I know my current and my resistance. I can find my power. So 4 amps squared times 15. 4 squared is times 15 ohms. 4 squared times 6. 4 squared is 16 times 15. Some days you can do that in your head, some days you can't. Equals 240 watts. So there's the power supplied by the battery. Let's put that here on our answer sheet as well. 240 watts. Okay, there's that problem done. Hopefully that shows you the method you should be applying to these questions. And now the next one I'll work through has a similar sort of diagram, but we have different information. So in this circuit, a 1 amp current flows through this 8 ohm resistor. We want to find the equivalent resistance of the circuit, how much current is through this one, and how much power is supplied by the battery. So a lot of similarities, but not the same problem. We're going to do some similar strategies. We're going to redraw our circuit, and we're going to start by unbending this wire. We're going to straighten that out. So my first picture is going to have my battery. Often we use V, sometimes we use an epsilon. That's just historical. So I've got my 3 ohm, got my 10 ohm, and over here on this branch I've got an 8 and a 2. You see they're both in a line, no branches in between them, so those two are in series. Straighten out that length of wire, get the kinks out. 8 ohms, 2 ohms, and I'm going to fill in that I know my current is 1 amp. What this tells me, some places I'm going to go with this, if I know the current, I know the resistances, I can find the potential. These two have to have the same current because they're in series. This branch and this branch are in parallel. They're going to have the same potential. So these are places we can go with this. Okay, I'm going to start by doing my series combination here. These two are in series because they're in a row with no branches between them. So my R equivalent is just 8 ohms plus 2 ohms equals 10 ohms. I'll redraw my circuit. I'm going to take out the 8 and the 2, and I'm going to put in that equivalent, which is 10 ohms. So the 10s are connected top to top and bottom to bottom. They have the same potential. They're in parallel. When we add things up parallel, we have to do the reciprocals. I'm putting an S on this one for R equivalent series, a P here for R equivalent parallel. 1 over 10 plus 1 over 10 is 2 over 10. Take the reciprocal of both sides to get 5 ohms. Okay, I'll redraw again. I'll take out my 2 10s and put in my 5. Okay, if I look here, I go straight from the 3 into the 5, even though I go around a corner. There are no branches or anything. These are in series because they're in a row. That means they're going to have the same current. So my R equivalent then is 3 ohms plus 5 ohms to give me 8 ohms. So my equivalent resistance of the circuit is 8 ohms, my total equivalent resistance. Okay, what's the current through the 10 ohm battery? So let's go back to what we know. I know there's a 1 amp current going through this 8 ohm resistor. So I'm going to think about this branch to this branch. This 10 ohm resistor was the series combination of this 8 and this 2. Because this is a series combination of these two, it has the same current. Because series has same current, so this is also 1 amp. Series, same current. If I know the current and the resistance, I can find the potential. So my potential V is equal to I times R, 1 amp times 10 ohms to give me 10 volts. Okay, now what do I know? I'm trying to find the current through here. I know that this 10 and this 10 are in parallel. Things in parallel have the same potential. So if this resistor has a potential of 10 volts across it, this resistor also has a potential of 10 volts. So 10 volts here, that tells me that my current, since V is equal to I times R, I is going to be V divided by R, equals 10 volts divided by 10 ohms equals 1 amp. Okay, so this also has a 1 amp current running through it, 1 amp. Current through the 10 ohm resistor, 1 amp. All right, power supplied by the battery. So why don't I come down here and finish my last diagram. The 3 and the 5 combine to give me an 8. To find my power, different ways to do it. We know that power is I times V. If V is I times R, then that's the same as I squared times R. I've got an awful lot of information about my currents now, so why don't I see if I can figure out my current running through this circuit and use that to find my power. Okay, so let's think about where did this 5 come from. This 5 was the parallel combination of these two 10s. I added my two 10s in parallel and I found an equivalent of 5. Things in parallel have the same potential, so this 5 ohm resistor has the same potential that each of these 10s had. They both had 10 volts across them. So this 5 ohm resistor carries 10 volts across the end. That means I can find the current running through this 5 ohm resistor. I is equal to V divided by R. 10 volts over 5 ohms equals 2 amps. That makes sense from a physics point of view. If I've got 1 amp here and 1 amp here, put those two guys together to get this one. You kind of got to have 2 amps. Okay, so we get 2 amps running through this one. We know that this 8 is a series combination of the 3 and the 5. Series means same current. So if there's 2 amps running through this one and this one, there's 2 amps running through this one. So my power is going to be 2 amps squared times 8 ohms. 4 times 8 gives us 32 watts. Okay, so there's some good resistor examples.